Good morning. Welcome, ladies and gentlemen. Welcome to the Technical Forum of Hydrogen and Fuel Cells Europe of the Hannover Fair 2022. My name is Bernhard Jekel. I'm the moderator for today here on this technical stage. And we have a whole bunch of interesting cutting edge presentations of the newest technology. And today, the first speaker will talk about the production of bipolar plates as prototypes and in series. And he's manager of development, laser cutting, and e-mobility. Please welcome with a great applause, Harald Liebhart.
Morning. So, hello and welcome also from my side to today's presentation of a manufacturing solution for metallic bipolar plates welding. And my name is Harald Liebhart. I'm at Weil Technology responsible for development of laser cutting technology and e-mobility products. Let me shortly introduce you the company Weil Technology. We are a family-run company founded at 1987 from our CEO, Mr. Wolfgang Weil. We are located in Mülheim, what is in the very south of Germany, about 40 kilometers in the south to Freiburg. We have two offices, one in Detroit and one in Shanghai, both with sales and service department. And we have a daughter company, Schal Technology, what is providing the servo press technology for us. This is located close to Stuttgart. With about 220 employees, we have about 1,000 customers worldwide and a summary of machine installations of more than 4,000 machines. So, in summary, we have more than 30 years experience in laser processing technology, especially, of course, in laser welding and in laser cutting technologies. Today, we want to talk about the solution for laser welding of metallic bipolar plates. And here we are in cooperation with the companies von Orden and Zeltwange as a member of the German Fuel Cell Corporation. Shown here on the slide the complete process chain, what is provided by the German Fuel Cell Corporation. All companies with their core competence inside, with their modules, and we are located here with mainly with the laser cutting technology and with the laser welding technology. Today we want to talk about the laser welding. So we at Weil Technology started an early research for the welding technology for metallic bipolar plates already in 2018, and this time, of course, with a Cartesian guided optics. What changed in case of the needs of the high output of the production lines today to remote welding technology. So today we're talking about welding speeds of 1,000 millimeter per second, what is required for the output of such a production line. And as you can see here in the diagram, a spot diameter of more than 80 micrometer is required to get a feed reserve of about 20%, what is recommended for our machine technologies. With this more or less very big spot diameter, you have a big influence for the thermal impact to the plate during the welding process, and this results finally in a distortion of the surface of the plate. What is for your product quality, of course, not good. Yeah, that's why we at Weil Technology developed the dual Scanfield technology, what gives us the opportunity to reduce the single speed of each scanner system and use a very small spot diameter to reduce the impact, the thermal impact to the plate during the welding. The dual Scanfield technology is working with processing with two scanners, time parallel on one plate with a small overlapping area, and this gives us additional benefits that we can, of course, increase our processing window. Here you see a comparison between a single scanner solution for an output of 1000 millimeter per second comparing to our dual Scanfield solution with the same final output. And as you can see, we more than doubled the process stability with that solution here. Oops, sorry, this was one side too far. Also here you can see now specifically for our optical setup, the process window is very high. So in summary, we achieved a very high process stability with this technology. We reached more than 20% feed reserve for the process, and of course low heat impact to the material during the welding process based on a very small spot diameter. Additionally to that, there are more benefits coming out from this solution. One of that is the heat management, what we can offer you. That works with the contour path direction, what we now can orientate symmetrically, start welding from inside of the blade symmetrically to the outside with the contour distribution. And this, of course, affects also in the thermal impact what is symmetrically, and gives you, as a result, a very flat condition of your plate at the end. Especially relevant for material thicknesses less than 100 of less than 100 micrometer, where the heat impact is more critical. Yeah, we can see here a sample of tooling. We use typically a double mold tooling and locate our two Scanfields over that so that we can simultaneously weld these parts. And as you can see here, a further benefit of this solution is that we have a complete static condition between the tooling support and the scanners, what gives us, in summary, or effects in a very high accuracy what we can realize. Our processing area is here at our system 500 to 350 millimeter for the maximum plate dimension for a single load. For a double load or double mold technology, we are limited for plate dimensions 500 to 165 millimeters. The next big challenge in laser welding of bipolar plates is, of course, the clamping and the tooling technology. Here the requirements are extremely high. That means we're talking about a zero gap condition, less than 10 micrometers. We need a complete equalized distribution of the force all over the tooling. And we need a prismatic compensation of the tooling. And of course, at least we need a very fast clamping and unclamping time. All these challenges are already managed from Weil technology in our prototype module, what is already patent pending, and what is implemented with automated clamping technology and installed in our lab in Mülheim at Weil technology. Coming to the industrial production solution for the PEM cells. Here we are based on a 4-station rotary table with 2 welding modules, each of them equipped with dual Scanfield technology and automated clamping technology. For the raw material feeding, we use precision magazine trays, which are supported from vertical magazine exchangers, what gives you also the autonomic of your system and can be enlarged as your requirements are. We feed from the support side into the toolings, or stack it into the toolings, which are located on the rotary table, one into the welding modules, and coming out easily on a belt system, or in the best condition on the loading tray of the leak test device of our system partner company Seldwanger. The working range, as explained before, 500 to 350 millimeter for maximum dimension of single loading, 500 to 165 for double mold technology for high output, and an absolute welding speed per single module regarded of 1000 millimeter per minute. All our tooling supports are prepared and equipped for interchangeable toolings, so you are safe for the future. We are very flexible on that side. Can use for future products. Coming to the SOFC solution of this machine, it's very similar. Here we're talking about multi-layers at the SOFC plates. And so we are able to stack up to 4 components. Doesn't matter if it's plates or spaces between. And so we have, of course, 4 loading supports here. The welding technology itself is the same, but we use additionally active toolings to do a pre-stacking with the right accuracy inside these toolings before we run them into the welding modules. From the outside, it's similar. The only thing what is really special here, we did also research, of course, for the welding technology of these plates, and the difference is comparing to the PEM cells that we have a material thickness of 300 to 500 micrometer, and we need a different welding technology. So we use an oscillating welding technology in that case, and this limits is the limitation of our welding speed here of 320 millimeter per second per module. Coming to the scalability of the system, we are starting with prototype module, can be added with automated loading and unloading, series production line with only 1 module, or scale up to the full 2-module version. Typically, for example, for 3-meter contour pass lengths on a plate, we're talking with the one station, with the one welding station inside of an output of about 1.5 to 1.8 million plates per year, and here, of course, the double of it. Finally, is to say that all the slides before I've shown you is not only a preview. We have already the hardware in-house in our lab in Mülheim, and are able to do prototyping for you there with the complete series equipment for the series module, with the dual Scanfield technology, with the automated clamping device, and of course we assist you in pre-engineering of your plate design, especially for optimization of the clamping and for the welding technology. Additionally to that, we have, of course, also the cutting technology for the Bipolar plates in-house, so also there we can provide prototyping for you. And now I say thank you very much for your time, for your interest in our machine technologies, and I hope to see you soon in our booth here in Hall 13 at D63 for further conversations, discussions, and questions. Thank you.
Thanks a lot, Harald Liebhart. You managed the problem to get a 30 minutes presentation on a 10 or 12 minutes plate.
Thanks
a lot.